Today we're going to look at section 4.1, graphing quadratics in standard form. Our objectives are to be able to graph a quadratic when it's given to us in standard form and to be able to find such things as direction, y-intercept, and vertex, among other points in order to graph a sketch. So the standard form for our quadratic function is f of x equals ax squared plus bx plus c. Now you might be used to seeing instead of an f of x a y value, but if you remember, we have our xy notation, which would look like this, ax squared plus bx plus c. And we also have what we call function notation, where we have our input and our output. For today's lesson, we're going to be dealing with most things in function notation. We have some important things that we need to find when we have standard form. One is the direction. If you remember, a parabola either has an upward facing, what we consider looking like a U, or a downward facing U. It's up if a is positive. Okay, and if our a value is positive, it goes up, and if a is negative, it faces down. Okay, our vertex is a point, x comma y, and to find the vertex, we put in for our x value negative b over 2a. If we evaluate that, we get our x, and to figure out the y, we just take our function and input whatever we got for the x. And this is how we look at that notation. Here's our x, here's our y. When we have a vertex, if you remember, our parabolas are symmetric, okay? Which means that I can cut them in half, fold them, and they would line up perfectly with each other. So our axis of symmetry, which is our line of symmetry, goes through our vertex, and it's a vertical line, so all vertical lines are x equals a value. And that value is the x value of our vertex, which is negative b over 2a. And we're going to use that line of symmetry to help us graph. The next thing that's important is our y-intercept. Our y-intercept is whenever x is 0. And if I substitute 0 in for x, if you notice my a value, a times 0 squared, would be 0, plus b times 0 is 0, which means I'm just going to be left with c. So I can easily find my y-intercept by looking at the c value. Now, because our parabola is symmetric, once I have a y-intercept, it's really easy to find its symmetric point. So we're going to find a point symmetric to the y-intercept. So let me just give you a picture. I can't give you an exact answer because we're not dealing with a real problem here, but let's pretend I have a vertex and a y-intercept. So I know my parabola looks like this. I should know that I have an axis of symmetry. It's cut in half. So if I graph this side, I should be able to find a point that's symmetric to my y-intercept, which means it's the same distance and height away from my line of symmetry. So we're going to be using that to help get a nice sketch. Now you can find any other point you want on this graph by picking any sort of x value. So x equals a number. And all you do is evaluate our function for that number to get our output. So we can find any number of points, x comma y, by taking a value. Say I pick 2, substitute 2 in, you can get a y value. I can put a negative 3, get a y value, and then you can plot as many points as you want. So let's go through a couple of examples. So the first one is f of x equals 3x squared plus 6x minus 2. So let's ask ourselves a couple of questions. One, what direction does this face? Well, a is positive, so this is going to face up. The next important thing is, where is the vertex? Well, the vertex is a point, x comma y, and I find the x value by doing the opposite of b, or negative b, over 2 times the a value. And this should hopefully all be reviewed from your algebra class. So this gives me an x value of negative 1. And after I get negative 1, what I'm going to do is substitute it in back into my problem. And if you remember our function notation, this is what we did. Our input is negative 1. Our output is 3 times negative 1 squared plus 6 times negative 1 minus 2. This is going to give me a positive 3 minus 6 minus 2, negative 3 minus 2, which is negative 5. So I'm going to plot the point, negative 1, negative 5. Next thing I want to find is my y-intercept. It's the easiest point to find in standard form, so I'm going to put 0. My c value is negative 2. So I'm going to go to 0, negative 2. So far, since I know this is an upward facing parabola, I can kind of see the shape. But if I look at the axis of symmetry, this kind of imaginary line that cuts my parabola in half, it's going to go through the vertex. And what it's going to do is give me kind of a way to see where my symmetric point is. So if I look here, this is where my y-intercept is. It's 1 away from my x symmetry. So if I go 1 away in the opposite direction, I can get a point that's symmetric to the y-intercept. And a lot of times we'll ask you this. So if I look, it's -2, comma, -2. So now that I have that, I can do a light sketch of my parabola. Go like this and curve up. Hopefully you'll be able to do a little bit better job not doing it on a computer. Okay? And that's all we need to do. Now we're going to talk about later in the unit of finding what we call x-intercepts, okay, where the graph crosses the x-axis. That's not as easy as the y-intercept. We have a couple of different strategies. You might remember them. We could factor and solve using what we call the zero product property. We could use quadratic formula, and we could use something later that you might not be familiar with, which is called completing the square. All of these we will hit later in this chapter. So let's look at the next one. All right, so this one's going to face down because my a is a -1. So I'm just going to do that to help remind me. My vertex, I'm going to do the opposite of b over 2 times a, which is a -1. So this is going to be -4 over -2, which gives me a +2. So to find the y value, I'm going to take my input, which is a +2, and anywhere I see x, I'm going to substitute in. Whenever you substitute in, it's nice to use parentheses for just the value you're substituting. Plus it helps. So I could type this in exactly how I see in the calculator. Remember here I'm only squaring a +2. I'm not squaring the negative. So this actually becomes a -4 plus 8 plus 5. So this is 4 plus 5, which gives me a value of 9. So I'm going to go to 2, 9 and graph my vertex. My y-intercept is just 0, comma, the c value, which happens to be a +5. So I'm going to go to 0, 5. So some of you will be able to do this without graphing this axis symmetry, but it might help. So if I graph that, I can see that there's a symmetric point right here. It's the same distance away from my axis of symmetry. So my symmetric point, okay, for my y-intercept is going to be 4, 5. Okay. So now I can graph my parabola, faces downward. And as we get further in the chapter, we'll be a little bit more accurate by adding in the x-intercepts. And that's my graph. Now you might remember how to find those, and if you do, you're going to be well ahead of the game once we get to the later parts. Let's try another example. Okay, this one's going to face up. The vertex, again, is the opposite of b, which opposite of a -6 is a +6, divided by 2 times a +1, which gives me 3. Okay, I'm going to substitute that into my function. So I'm going to get 3 squared minus 6 times 3 plus 9. So this is 9 minus 18 plus 9. Okay, so 9 minus 18 is -9 plus 9 is 0. So I get now a vertex at 3, 0. Let's find my y-intercept. My y-intercept is going to be 0, 9. So I'm going to go to 0, 9. And I can find my symmetric point. Okay, my symmetric point is going to be 3 away from my line, going in the opposite direction. So my symmetric point to my y-intercept happens to be 6, 9. Okay, this helps me because now I can draw a sketch. Now this one's kind of nice because I actually know what the y-intercept or the x-intercept is. It actually is 3, 0. So when we get to it later, you don't even have any work to do. It happens to be the same as the vertex. And let's try our last one. This one also will face up. Okay, to find my vertex, opposite of b over 2 times a. So this is -2 divided by 1, which is -2. So my vertex is -2. I'm going to take that value and input it into my function, which is 1/2 times, again, use parentheses to make sure you don't make a mistake. So this is 1/2 times a +4, which gives me a 2. 2 times -2 is -4 plus 3, so I get -2 plus 3, which is 1. So I'm going to go to negative 2, 1. My y-intercept, again, is just 0, comma, the c value, which happens to be a positive 3. And then, again, I'm just going to draw this line to make it a little bit easier for you to see. I can now find my symmetric point. This is 2 away from the green line, so I'm going to get a symmetric point. Again, to the y-intercept is going to be negative 4, 3 for our purposes. So now I can just do a light sketch. Now, if you notice, this one never hits the x-axis, and that's going to be something we talk about later. This one has no x-intercepts, okay, which also makes problems a little bit easier later. Hopefully you feel a little bit better about graphing quadratics in standard form. I didn't take the time to do extra points because we're just doing light sketches, but you can always feel free to take any x value and input it in to find other y values. But hopefully you feel easy enough to find the direction, the y-intercept, and the vertex, along with finding that symmetric point to give us